I know, everybody did so well, it means I'm not sure.
No, it just means you're teaching us well.
Oh, I appreciate that. You know what, the recording has started too. There you go.
And then I think,
So we're ready to get started then with the new material. The new material, wait, no, we're not ready to go to the new material. Hang on a minute. Are you ready? Here we go. 1, 2. 1 is 2 independent samples with population standard deviations. You would be using a Z. Number 2 is 2 independent samples with standard deviations, with sample standard deviations. You would use a T, assuming equal variances. Number 3, 2 independent samples with sample standard deviations using T, but assume unequal variances. Then we have 2 related samples using T and proportions using Z from our last lecture on Tuesday. Those are the 5. I'm about to show you some questions. Tell me whether it's 1, 2, 3, 4, or 5. This has got to be probably the hardest part of quiz 3, is identifying which one you're reading. Then follow the directions on how to solve it. Here we go. Here's all 5. There they are. Independent samples with Z, independent samples with T, assumed equal population proportion. Independent sample T, assumed unequal population proportions. And I want to highlight something, since we're recording. These 2 right here, on the quiz, I said if it doesn't tell you that the population variances are assumed equal, assume they're not equal. But, in real life, when you have independent samples and you're using the sample standard deviations, you're supposed to be doing what we're learning today, which is an F test, to compare the variances to determine whether you should be using assumed equal or assumed not equal. But on the quiz, you're going with what we talked about. Either you're being told they're assumed equal variances for the population, or you go ahead and assume they're not equal. This will be a separate problem on the quiz, this F test, which we're going to learn today. But here we go. I'm going to start with this first one. Do women really spend more money on shopping as compared to men? A survey found that women spend an average of $43.87, while men spend an average of $34.54 per week. Assume that the data were based on a sample of 50 men and 56 women. The population standard deviations of spending for men and women are $32 and $25 respectively. So specify the complete hypothesis and whether women spend more money on shopping as compared to men at a significance of 10%. State the conclusion using the confidence interval approach. Is this number 1, 2, 3, 4, or 5? 1, we all agree it's 1?
yeah.
We 1? Okay, hang on. Let's think about it now. Hang on. Should we keep going? Right here? This is 0. This is 0. Should the alternative hypothesis be greater than, less than, or not equal to? I'm sorry, not equal to, right? The alternative hypothesis. We're reading this. Now hang on, I don't know the answer yet. I gotta read it. Should I read it out loud while I'm thinking about it? Because when I hit that spot that will tell me, then I'll stop. Should I try it? Do women really, well this almost gives it away. Do women really spend more money on shopping as compared to men? Okay, well which numbers are women then? Women are 43.87, men are 34.54. Okay, well the sample shows women do spend more because it's a little more than men. So when I subtract the 2, are we going to be above 0 or less, greater than 0 or less than 0? Above 0, so this is greater than 0, the alternative. The null is less than equal. All right, you're with me? Do you see how I came up with that conclusion? I said to myself, this is one tail because it's stating that women spend more than men. It doesn't say women spend differently. It didn't say women spend less. It said more. Then I looked at the 2 samples and saw that the women's number was bigger than men's. So if I subtract the left-hand one minus the right-hand one, I'm going to get a positive number, not a negative. And that's what we're trying to prove, or the research is all about. So that's why I put it in the alternative. 1 minus the other would be greater than. Go ahead.
At the top it shows women then after it shows men and women.
What are the samples though? The survey found that women spend 43.87, men spend 34.54. So There, where is it switching it off? Okay, on the sample size, it did switch it men and women.
And standard deviation.
And the standard deviation, but those don't matter. It depends. If you are somebody who says, I want to take women minus men, and I see you're subtracting 3454 minus 4387, then yes, your alternative would be greater than 0. But kind of this final sentence kind of gives it away what we're trying to do here. Specify the competing hypotheses to determine whether, and here's the sentence, women spend more than money than men. So that's why you gotta go women minus men. Because of that sentence right there. That's what the research is asking to do in that order. Okay, let's try the next one. According to a health report in Boston, female residents in Boston have a higher average life expectancy as compared to male residents. You collect the following sample data to verify the results of this report. You also use historical population standard deviation, 8.2 years for females and 8.6 years for males. Let me stare at this for a second. Wow. Female mean is 82.1, males mean is 76.2. Number of females is 32, number of males is 34. Is this a 1, 2, 3, 4, 5? Another one in a row? We have 2 1s in a row? Are we sure? What gave this one away? The population standard deviation, and we were given means. We weren't given, whatever. I guess it wouldn't be proportions, would it? So now, here we go. Let me erase this. Let me erase. Which way would the alternative be? Which way? Is this a 1 tail or a 2 tail? Why say 1 tail? Because it says, do female residents of Boston have higher average life expectancies? There it is. And it's all about whether females have higher, so it would be females minus males. And it says females will be higher, so without even looking at the sample, I know the life expectancy of females in the sample is going to be a bigger number than males. So when I subtract females minus males, I'm going to be above or below 0? Above 0. So this one is greater than 0. This one's less than or equal to 0. See how I'm getting at it? Now, we just found out that our null hypothesis is rejected on this one. And you got to write a sentence to give me the conclusion as to what that means that you rejected the null hypothesis. What did you just discover? That's right. We can conclude that female residents of Boston have a higher life expectancy than female. That's what, if we ended up rejecting the null hypothesis. That the research that we put in the alternative trying to prove ended up being true. Exactly. All right. You got to remember, on this quiz 3, I'm putting some significant points on that conclusion sentence. What I mean by that is, it's not going to be a quarter of a point. It's going to be more like maybe a full point or a half a point at least. For probably 3 of the calculation questions at least, I'm going to ask for that final conclusion sentence. Here we goes another. A manager of an industrial plant asserts that workers on average do not complete a job using method A in the same amount of time as they would in method B. All right? They would not complete a job using method A in the same amount of time as using method B. Let me stop right there. 1 tail, 2 tail. They would not complete the job in the same amount of time. Huh? Why 2 tail? Didn't say that they would complete it faster in one method than the other. They didn't say they'd complete it more of them than doing it one way than the other. They just said it would be different, right? That it would be certain workers that the average do not complete the job A in the same amount of time. It's not the same amount of time. It didn't say more, it doesn't say less, it just says not the same. That's why it's 2 tail. So in this case, how come I keep losing the eraser because it's right here? In this case, this would be equal right here. Is that correct? No. I was trying to fool you. Not equal to would be the alternative. The equal's always in the null hypothesis.
Which one is it? Professor, which one is it?
All right, is that this one, right? Now let's read the whole thing. 7 workers are randomly selected. Each worker's completion time in minutes is recorded by the use of method A and the use of method B. The observations generates the following results. Mean difference is 3.3. The sample standard deviation of the difference is 2.8. 1, 2, 3, 4, 5. 4. How did you know it's 4?
Mean difference.
Mean difference was a pretty good, the mean difference is a good hint. Another one is the 7 workers are the same 7 workers that were measured before and then again after. Just different methods, but the same workers. That's what makes it really related. That's why it's number 4. Okay, let me think a minute. You ready? The null hypothesis could not be rejected. The null hypothesis could not be rejected. What's your conclusion? Put it in the words. Nobody? We can conclude that the workers on average using method A has the same amount of time is approximately the same amount of time as using method B, right? Because we were trying to prove it would be a different amount of time, weren't we? So we couldn't reject the null hypothesis, so we gotta say it was probably approximately the same amount of time using method A and method B. Or that the method A and method B were not different amount of times. We could even say that. That's also the same, saying the same thing in a different way. There's many different ways you can say it, but as long as you're saying the same thing, what the null, rejecting the null or not rejecting the null means, whatever the case may be. Here we go to the next one. A design engineer at Sterling Manufacturing, a supplier of high-quality ball bearings, claims a new machine process can result in a higher daily output rate. Here we go, output rate, how many? According to the production group is conducting the experiment to determine that the claim can be substantiated. By the way, the claim is that the new machine process can result in a higher daily output rate. 1 tail or 2 tail? I heard it back there, 1 tail, because you should, the word higher daily rate, not different daily rate, not lower daily rate, but higher makes it a 1 tail. I guess lower would too. Accordingly, the production groups conducting the experiment determined the claim is substantiated. The mean and standard deviation of the bearings in a sample of 8 days output using the new process equals 2,613.63, 90.78, respectively. A similar sample of 10 days output with the old process yields a mean of and standard deviation of 2,485.10 and 148.22, respectively. We can assume that the population variances of the 2 products are equal. 1, 2, 3, 4, 5. 2. That last sentence give it away? But also recognize that the standard deviations were being given to you as sample standard deviations, not populations. Now, I want to tell you about the final exam. After today's lecture, on the final, you're going to look at this and go, okay, this sentence is not there. The 2 population variances of these 2 products are equal. It's not going to be there. And on the final exam, I'm going to remind you that we're not assuming they're unequal, which would be number 3. Instead, it will say something like, make sure and conduct an F test to determine which hypothesis testing you should use. Do you get it? Because the F test is what's going to determine whether we're using 2 or 3. Those sentences telling you that the population variances are equal or they're unequal are going to be gone on the final exam. Instead, it will say, conduct an F test to determine which one you should use. And that's what we're learning today, is this F test.
So we have to do this again.
Which one to use on the final exam. And I'm going to remind you before the final. On the 3rd quiz, I'm going to be telling you if the populations are equal, just like this. On the quiz, this sentence will be there. We can assume the population variances of the 2 products are equal. Because that sentence is there, you know it's number 2. But on the exam, that sentence will be missing. And you gotta go, oh, I don't know if this is 2 or 3. But it will say, make sure and conduct an F test so you know that you'll know to do it. What you're learning today. It's so easy, that's why I'm stalling. Oh, the F test is so easy. So easy. My grandmother, she's dead. She could do it. She could. In her grave. That's how talented she was. This is Hayek, my Hayek grandmother, not McCarthy. Hayek. I'll make sure you guys knew the difference. Despite his inexperience, candidate A appears to have gained support among the voters. 1 tail or 2 tail? How do you know? Gained support. This is all about gaining support. 1 tail. Hey, I noticed you taking pictures. Do you think one of these questions might be on the final? Yeah. Really? But because I saw you take pictures, what do you think the odds are now? dang. What did you say? Had I not seen that just now, you never know those. Man, you gotta be more secretive. You can't give it away. 3 months ago, in a survey of 120 registered voters, 55 said they would vote for candidate A. Today, 41 registered voters in a sample of 80 said they'd vote for candidate A. Conduct a 95% confidence interval to determine if the null hypothesis can be rejected. 1, 2, 3, 4, 5. 5. There were no standard deviations. And these are numbers that you're supposed to turn into proportions. You're doing number 5, you're doing a Z, which is everything we learned on Tuesday, which is part of your homework that's due. Is there homework due on Tuesday?
Yes.
There is, but there's no class, is that correct?
Yeah.
Hey, I just want to remind you, if it's possible to, is there an Excel part this week? Oh, there isn't an Excel part. So forget what I was about to say. I was about to say, if it's possible to take the Excel and the written and put them in one email attached, oh my God, it'd make life so much better. Oh gosh, that'd be great. But we don't have an Excel, so I don't need to say that, so just forget what I said. Hang on a minute, you ready? The null hypothesis just got rejected. You need to write a sentence concluding what it means that you rejected the null hypothesis in this case. Should we write the hypothesis first? Should we write the hypothesis, David? Okay, let's write it, because I can see a lot of blank looks there. Hang on. You ready? Is this a one-tail, two-tail? You guys told me one-tail. And we're comparing candidate A before and 3 months ago and candidate A today. And the claim is that we think it picked up speed or got better, that the proportion's better. So if the proportion before is smaller and the proportion got bigger and you subtract the two, would you be below 0 or above 0? Below 0. So in this case, this would be a less than 0 and this would be greater than equal in the null. And I could be wrong, but that's the process my mind goes through trying to get this. I want to say it again to make sure. If the first proportions, A represents, let's see, the first proportion, is the first proportion what happened 3 months ago, or today is the second proportion, right? So 3 months ago, and the claim is that the proportion is getting larger, meaning getting more people voting as a proportion. So it'd be a smaller proportion, let's say 30%. Now it's a bigger proportion, 50%. You subtract the 2, it'd be a negative number. So that's why we're going with this hypothesis. Now, we just rejected the null. We just rejected the null. You need to put a sentence that concludes what it means to reject the null, that is greater than equal to 0. What does it mean in words? Anybody? Jumping in? Keep jumping. Are you on it? Candidate A has gained support today compared to 3 months ago. That's what we proved. Candidate A has gained support today compared to 3 months ago. That's what we proved. Just taking the words out of the story and write them what it is we've just figured out by doing that experiment. And it was based on 95% confidence. I'm sorry, go ahead. You got it?
Is this the last one?
No, we got another. We're going all day. I hope you packed a lunch. Oh, this is our last one. Here's our last one. A phone manufacturer wants to compete in the touchscreen phone business. Management understands that the leading product is less than desirable battery life. They aim to compete with the new touchscreen phone that guaranteed to have a battery life more than 2 hours longer than the leading product. Or let's just say a longer battery life, not necessarily 2 hours, a longer battery life than the leading product. One tail or two tail? One tail, a longer battery life means one tail, absolutely. A recent sample of 120 units of the leading product provides a mean battery life of 5 hours and 40 minutes with a standard deviation of 30 minutes. A similar analysis of 100 random selected new product, a product that we're making to beat that battery life, resulted in a battery life of 8 hours and 5 minutes, standard deviation of 55 minutes. Use the p-value approach with 5% significance to determine, hang on, 1, 2, 3, 4, or 5? 3 it is. It was 2 independent samples, and you're being given the sample standard deviations, and there's nothing about their population variances being equal. That's how we knew it was number 3. Are we gonna do well on this third quiz?
Yes.
We are?
Yes.
We are? Okay, I need to make it harder, because I didn't realize how confident you guys are. Wow. Man, you guys are really blowing the system. I don't know how you can't learn. All right, I want to refresh your memory where we're at here. This is your quiz. This slide represents your quiz. Right here, that number 1 was from right before the second quiz, that lecture about having the population standard deviations of 2 independent samples and using Z. That's right here. But also right here on the first lecture after the quiz was that you have 2 independent samples with sample standard deviations and using T. That's all from there. Then we went to related means the following week, but we focused on just T, no Z. Z won't be in the picture, so this should be easy to spot because the sample's coming from the same place. And then Tuesday was all about proportions, and then today is about variances. This variance, you may have something, yes, you're going to have something on the quiz, maybe either to calculate the variance, to answer a question. Here's the question that I'm looking to have answered. Calculate the F-test statistic and tell me whether you would be using equation number 2 or equation number 3. That's really what this is all about. Now, there's a little trick to it, and I don't remember why. It's been like 10 years since I taught this, because I took this out of the lecture 3 years ago when I taught this class. So it's been over 10 years. I don't remember why, but I remember there is a trick. That the number on top, the variance of the sample on top is supposed to be the bigger of the 2 variances of these samples. This is a sample variance, this is a sample variance, but you're supposed to quickly find the variance numbers, put the larger one on top to get that F statistic. Then you're going to use that F statistic to turn it into a p-value and compare it to the significance and tell me whether you reject or not. If you don't reject, let me repeat this, if you can't reject, then you have evidence that the population variances could be equal. Did everybody hear that? Now here it is, ready? You're doing this whole F comparison here, this variance comparison, and you're going to turn it into a p-value, and you're either rejecting or not rejecting. If you can't reject, that means the 2 variances are too similar, and you're using equation number 2, assuming the population variances are similar. But if these variances are far enough apart, and you reject compared to the significance, you take the p-value is less than the significance, and you can reject, then you're using equation number 3, assuming they're unequal variances, because the variances are so far apart from each other. That's if you can reject. So now, we're going, if you're following along, we're going all the way to slide 43. This is the last thing we have to learn from this PowerPoint. Boy, we have some fun stuff coming up though. And what's next week? Week 11, we have the quiz. Week 12 and week 13, boy, we have some fun stuff. Matter of fact, I can't remember if it's week 13 or 14 when we do regression. It has been communicated to all, you guys with me? All right, it's been communicated to all the statistics professors that regression is the most important subject that you'll be using in other classes, according to the other professors. That they want to make sure that you got regression down. So that's coming up after the next quiz is regression, which is a forecasting technique, which I used in real life in the job I was in very often. So it is important. Here it is. These are the 3 hypotheses, lower tail, upper tail, whatever. Here's the formula to get your F-test statistic, the variance of the first sample divided by the variance of the other sample. Again, whichever variance was larger is the one on top. So you're going to be at 1 point something or 2 point something will be your test statistic. All right? Degrees of freedom. If we were using the table, if we were going to use the table in the back of the book, degrees of freedom would be important. But basically there's 2 different numbers here, and it would be however many are in the first sample minus 1 would be the degrees of freedom related to that first variance, and however many are in the second sample minus 1 would be the degrees of freedom related to the second variance. Again, this is important if we were using the table in the back of the book, because you got to look up 2 numbers based on those degrees of freedom. But we're not. We're going to use Excel to solve ours. We're using Excel to do a table to find our p-value and critical value. And if we decide for 1 tail, And for two-tail, we're using this Excel equation. You ready? Equals F dot TEST, parentheses. You scan the data location for the first sample, comma, the data locations for the second sample, equals your two-tail p-value, which you would then compare to the significance. All right, let's get to an example. Blah, 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 blah. Look at how the hypotheses are written here. The hypothesis is not an equal or less than or greater than 0. It's the only one of everything we learned where it's one variance compared to the other variance. All right? One variance compared to the other variance is either less than, greater than, equal, not equal to. No, we're going to use Excel will give us the answers for one tail. Excel, what do we call it? An Excel table. An Excel table is the one tail answer, and then this is the two tail answer. If we need a two tail, we would use this. If we need a one tail, we would use that. Okay? All right, so blah, 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 blah.
Is this only for p-value?
This is, we're only going to do p-value. We're going to talk a little bit about the upper and lower critical values, but we're not doing confidence or confidence intervals.
So do we need to know critical value?
A little bit. All right, let's get into this example. You are a financial analyst for a brokerage firm. You want to compare dividend yields between stocks listed on the New York Stock Exchange and the NASDAQ. By the way, this example is like from the very first example from that lecture right before we took quiz 2. But this time we're trying to determine which formula to use. Or right here. There were 21 in the sample size from the New York Stock Exchange, 25 sample size from NASDAQ. The mean was 3.27, the other one was 2.53, the standard deviation was 1.3 and 1.6. Let me start right now. Can we do an F-test statistic from the information we have, yes or no? Can we do it from just this information?
Yes.
Why?
We have the standard.
Exactly. As long as you got that standard deviation, you can convert it to a variance. And which variance is going to be on top? New York Stock Exchange or the NASDAQ? Which variance will be on top? New York Stock Exchange, because the 1.3 squared is going to be a bigger number than 1.16 squared. The question is there a difference in the variances between the two, one tail or two tail? Is there a difference between the variances, one tail or two tail? Two tail. It's not saying is the New York Stock Exchange variance larger than the NASDAQ, or it's not saying is the New York Stock Exchange variance lower than the NASDAQ. It says is it different. That's what makes it two tail. It says use 5% significance. Here we go. Now, this is if you're using the back of the book, but I want you to see how this is done. You're not going to have to calculate this way. What you're trying to find is your upper and lower critical values to determine if your F statistic is between them or on the outside. If we're using critical value, which we're not, we're going to use p-value, but I want you to see where this comes from. The upper one, we would say, okay, what's the sample size of the first one? Oh, it's 21. 21 minus 1 is 20 degrees of freedom, and we would go to that, is it column or row? I can't remember, it's like column or row if we were using the chart. The other one, the sample size is 25 minus 1 is 24 degrees of freedom. Then we would look to see where they meet at 5% significance, and we would get, because it's two-tailed, we got to split the 5% in half, so it goes to 0.025, 2.5%, 20 comma 24, the 2 degrees of freedom. We look at the number there, 2.33. There's our upper limit, lower limit. We would then flip them now. We're putting the other variance on top and the other variance on bottom. 25 minus 1 is 24 degrees of freedom. 21 minus 1 is 20 degrees of freedom. We looked this up on the chart, but now we flipped them. So we're not going to the 20, the 24, and the 20. And we look and see that is 2.41, but you have to put 1 over it to get the lower interval. So 1 over 2.41 is 0.415. Let me show you on a graph. Here's 0.0415, way over here. Here we go, 0.43. And here's 2.33. Here are the two numbers. We then calculate our test statistic. we take the standard deviation of the first sample, 1.3, and square it. Take the standard deviation of the second sample, 1.16, and square it to get our two variances. We then divide. Our F statistic is 1.256. It falls between the upper and lower values, critical values. Since it falls between them, we cannot reject. These two variances are too much alike, and we're going to use equation number 2. Do you get it? Now that you see how it's done manually, here's how it's done automatically. I could not duplicate these numbers because it didn't give me the data, so I made up some new numbers. Are you ready? Here it is. This goes back to one of the homeworks we have. In this case, this F test, you're going to use it the same way that data analysis that we all installed. You're going to the same spot there, but look for the two population or two sample variance test. I think that's what it's called. So what tab should I click on to find this? Data. Now there it is, data analysis. I open that up. Look at the list. There's F test 2 sample variances right there. That's the one you want. F test 2 sample for variances. It says it right in the instructions right here. Okay, let me hit equals. Here it is. It looks very similar to the other ones. Use labels. Click on labels because we're going to include labels in our scan of each one. Wait a minute. What am I doing? Cancel. Cancel. I don't know which one's on top and which one's on bottom. So how am I going to find the variance? How am I going to determine which is on top, which is on bottom, which is the first? There we go. I don't know what you just said. It sounded right. Equals VAR, right? Parenthesis. Now the data. There it is. Here's the variance for the first data. 56.6. Let's do the second data. Equals VAR. Whoops. Equals VAR, parenthesis. Find the variance of the second data. There it is. 57. Which one goes on top? Which one's going to be the first? Oil. There it is. So here we go. Data.
Is this for one tail?
This is one tail. This is one. No, we're doing one tail and two tail. But this one's one tail.
The Excel table is only for one tail.
The Excel table is only for one tail. Data. F test for 2 samples. Labels. Which one's on top? We're going to use oil on top. So I'm left click on oil, hold down my left click, scan the whole range. The second data is going to be gold. Left click on gold, scan the whole range. Make sure labels is checked. The significance 5% says right there, use 5% significance. I'm going to put where should I put the output? I'm going to put it on a new worksheet. Matter of fact, I already did it on a new worksheet right there, but we'll do another one. Here we go. Boom. There it is. Let me make it wider. Okay. Stare at it. Stare at it. Let me ask you some questions. What's our F test statistic? What is our F test statistic? There it is. 1.01766 blah, 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 right? All right. What is our p-value? 0.4886. What are we comparing that to? Which is how much significance? 5%. Is our p-value greater than or less than 5%? Stop. 0.05. Is our p-value greater than or less than 0.05? Greater than. 0.4887, whatever that is much higher than 5%. So do we reject or not reject? Do we reject or not reject? Can't hear you. Not reject. Our p-value is so high we can't reject. Now, here's how you pass this quiz. Do we use equation 2 or 3? You just not rejected. You could not reject the null hypothesis. Do we use equation 2 or 3? 2 it is. 2. You couldn't reject it, so those variances are too close together. And that population variances could possibly be equal because we could not reject this null hypothesis. You get it? All right, let's pretend this is a 2-tail. Let me go back. Hang on, let me get rid of this. Delete that whole shit. There we go. Now I'm going back. Let me get rid of these. Again, let me get rid of these. okay, equals F dot TEST, parenthesis, the range of the first data. The first data we said was gonna be oil because it has a larger variance, is that correct? So I'm doing oil, whoops, I can't include the word oil, stop that. There, right there. F12 all the way to F23. Oh, good, hang on. F12 all the way to F23, comma. Now where's the other data? D12 to D23, ending parenthesis, let me hit equals, the two-tail p-value, which is usually the one tail times 2. You guys said the one tail was like 0.44 or 0.45, I can't remember what you said it was. As a matter of fact, let's look it up again. What was the one tail? 0.4886, so you double that, which will be this two-tail, which is right there, 0.977. This is so far above 5%, there's no way we can reject the null hypothesis. These two standard deviations are really the two variances from these samples are close enough together for us to say that probably the population variances are equal, and we're using equation number 2. Does everybody see how this is used to determine whether you use equation 2 or 3? Everybody see it? Go ahead.
Just to make it clear, so if you cannot reject, then they are equal?
If we can't reject, that means these two variances are so close together that we're going to assume the populations are close together. If we could have rejected this null hypothesis, then we have evidence that these two variances are far enough apart that we can go ahead and use equation number 3 and assume the population variances are not equal. Everybody see how that's used? How are we doing on time? Oh, we're doing well. We got an in-class assignment and we only got about 15 minutes. Look at my notes here. Boy, I have a good life lessons, but I'm going to save it. I'm going to save it for after the third quiz.
Are we only doing this with Excel, or will we have to use that?
Yeah, we're only using it either this F test or Excel to find whether this can be rejected or not rejected. We're not doing confidence intervals, and we're not manually using the back of the book, but you can see how you can find that critical. We're just using p-value. We're just using p-value if it comes to quiz 3. And the Excel tables, if it's one tail, you see the p-value on it. Easy, right? You're all worried about new material, and it's easy.
What are we using that for?
This is how you would manually calculate it if you didn't have this.
Oh, we're not doing that.
No, we're not. Because, and the only way you can use this is if you're given the raw data, and the only way you can use this is if you're given the raw data. So either you're going to be given this already calculated, or given that already calculated. Either or. And you got to analyze it and tell me, are you using equation 2 or 3? You're going to analyze it and tell me if you're using equation 2 or 3.
No.
Get it? Everybody get it? That's almost too easy. I can't give it away more than that. Why don't I just go ahead and read the question to you? No, in my head. All right, how's that? Are we ready? This count? We read it. You ready? This is your in-class assignment. Leave your ducks and rabbits on the back, please, so I can. I want to keep track and see how many people do ducks and rabbits. Despite his inexperience, candidate A appears to have gained support among voters. Boy, this sounds familiar. 3 months ago, in a survey of 120 registered voters, 54 said that they would vote for candidate A. Today, 41 registered voters in a sample of 80 said that they would vote for candidate A. Construct a 95% confidence interval to determine the null hypothesis can be rejected. Stop. Don't construct a 95% confidence interval. Instead, follow these directions. Matter of fact, critical value approach. Let me get this up. There. Let me save. There. Ready? Write a null and alternative hypothesis. Show your calculation details and use the appropriate Excel equation to use the critical value approach at 12% significance to determine your conclusion about the null hypothesis, either you reject it or not. Then also include a final sentence defining your conclusion in words. I want the hypothesis, I want your work, I want that Excel equation, I want you to use 12% significance, reject or not reject the null, and give me that final sentence, what it means. All right, good luck. This is your first in-class assignment that I cannot help you whatsoever. I can't answer a single question. Not one. This is it. You're on your own. You only can learn from each other. If you decide to leave and not talk to at least 2 other students from different rows, that's on you. Did I put that on video?